Hi everyone, my name is Haley Metzger and today I will be explaining problem number 3 from the expert TA homework on displacement, velocity, and acceleration. As you can see, this problem has 3 parts. So it says find the following for path D, and we'll have to find the distance traveled in meters for part A. For part B, we're finding the magnitude of the displacement in meters, and for part C, we're finding the displacement in meters. And then here is path D that we will be focused on. So things to know when solving this problem, you need to know what distance traveled is, and it is the total length of the path traveled between two positions. And then the magnitude of displacement is the change in position with no regard to direction. And then the equation for this is the absolute value of the final position minus the initial position, and that's what we'll be using to solve. And then displacement is simply the change in position, and displacement is a vector, meaning that the direction matters. So for this equation, you'll notice that there's no absolute value, and it's simply final position minus initial position. Now that we know that, we're ready to start solving. So part A, we're going to be solving for distance traveled. So with this one, we're taking into account total distance here. So we need to know that the initial position is the 9-meter mark. We need to notice that the final position is the 5-meter mark. And we also need to notice this 3-meter mark where the object is changing directions, turning around and going back. So keeping these numbers in mind, we're going to solve for distance traveled. We're using the absolute value because the direction does not matter here. So for this first line segment, the final position is going to be this 3-meter mark for just this section. So we're going to do the absolute value of 3 meters minus the initial position of 9 meters, plus the absolute value of 5 meters minus 3 meters, for 5 meters being the final position, 3 being the initial position. And then that's going to work out to be the absolute value of -6 meters plus the absolute value of 2 meters, which works out to be a distance traveled of 8 meters for path D. Moving on, we're going to be doing magnitude of displacement for part B. And we'll remember that the equation for this is the absolute value of final position minus initial position. Like we stated earlier, final position is 5 meters, the initial position is 9 meters. So the absolute value of 5 meters minus 9 meters is 4 meters for the magnitude of displacement for part D. And then finally, part C, we're solving for the displacement. The equation for this is delta x, which is change in position, equals final position minus initial position. Like we just stated, the final position is going to be 5 meters minus the initial position of 9 meters. Notice that there's no absolute value because direction does matter. It's a vector. So the displacement is going to be -4 meters. Some things to remember when you're solving this problem is that you need to remember the absolute value and the magnitude of displacement. That's something that is a common mistake, is forgetting that, because the direction doesn't matter, so the absolute value is necessary. When you see this word magnitude, you're going to be needing an absolute value. And then another thing to note is that there is a difference between distance traveled and magnitude of displacement. So the distance traveled is going to include this entire line. So you're adding up all of the distance. Whereas for magnitude of displacement, you are just finding the difference between the initial position and the final position. So the distance traveled can be larger than the magnitude of displacement for that reason. Then hopefully this explanation helped you get a better understanding of the difference between distance traveled, displacement, and magnitude of displacement. Thank you.